Hey guys, so we're going to discuss the last section of chapter 9, which is obviously 9.4, and this is going to correspond with learning objective number 8, which is, as the title suggests, all about the applications of the within subjects designs, the different ways that we can use them to compare two or more conditions or two or more treatments, and then also the statistical analyses that correspond to each of the different ways that you can do this, and the strengths and weaknesses of each of these types of applications. Remember that, or you probably have already figured this out by now, but a within subjects design, really the most common application is that it's ideal for small populations or samples that you can't, there's not a larger, that there's not a larger, what's the word I'm looking for, population to pull from. There's just not that many participants or subjects to study. And so this would be people like Olympic athletes or people with multiple personality disorder or dissociative identity disorder, or women who are taller than 7 feet. Your book has lots of different examples like that. If it's a relatively small population, within subjects is really going to be better for that, again, because you don't need as many participants. It also is ideal for situations with where you're concerned about a large variability or large individual differences between the participants, because again, that would be harder to do a between subjects design because you're not accounting for those individual differences. There's that static we talked about. Within subjects, you're able to remove that as a factor. So let's get on to the most simple application. Again, just like with between subjects design, the most simple application is just two treatment conditions, right? Two levels of the independent variable. And so the advantages and disadvantages of this is the exact same as the between subjects design we talked about in chapter 8. So it's easier to conduct, it's simpler to understand, it is easier to find that difference and see that difference between the subjects, between the dependent variable scores. If the independent variable is having an effect, it is easier to see that with two treatments a lot of times, because you can maximize those differences, right? It's also easier to counterbalance. We talked about in the last video counterbalancing. It's easier to do that, to balance those order effects with less conditions, with less groups. When you increase all of that, it makes it a little bit more complicated in general, especially for counterbalancing. But the disadvantage is, again, there's only two data points that you're viewing, two levels, two groups. And so the actual relationship between your independent variable and dependent variable may be more complicated than that. And you may need to study more conditions or more levels to get the full picture. So the data measurement for interval and ratio scale, that numerical data, is going to be a repeated measures t-test or a single factor repeated measures ANOVA. And again, that single factor, remember, is that single independent variable. And so the more detail about these statistical analyses, again, is in chapter 15, but for now, you just know that that's what you would use. Now, if there's ordinal or rank data, we talked about in chapter 8 for between subjects, if it's not, it's categorical, it's not numerical, and you can't calculate the means to compare the means, because remember, with the t-test and the ANOVA, you're comparing the means of each group. When you can't do that because of the ordinal data, then you are going to use a Wilcoxon signed ranks test or a sign test. And your book talks a little bit about that, but there's more about that in later chapters, and also other textbooks that go into more detail about those kinds of tests, because those aren't necessarily used quite as often as the t-test and the ANOVA. So what do you do if you want those multiple groups, those multiple levels, multiple treatment? if you want more than two. Um, the advantages of this is that you are, again, more likely to reveal the actual true relationship, the functional relationship between the independent variable and the dependent variable, because the more real life example is more complicated, right? There's going to be more levels involved. Excuse me. But remember, hold on, we'll get to that in a second. And then also, another advantage is that it produces a more convincing demonstration of the cause and effect. So, if it is consistent, like if you're, measure them and you measure them again and you measure them again, and you have those multiple measurements, and there's a difference detected there, then you feel more confident in that cause and effect relationship than if there was only two data points to measure. But remember, just like the between subjects, the disadvantages, one is that if there's too many treatment conditions, if there's too many levels measured, too many groups, then the distinction could become so small, so subtle, that you don't see that difference. It's not statistically significant because you have divided that up. So again, it's all about balancing and figuring out what works for your variables. If you are able to maximize the differences between those conditions, then you could do multiple treatments. But if it ends up being very subtle, subtle differences in the independent variable, subtle changes in the independent variable, the dependent variable changes are likely to also be subtle. And then also a disadvantage for within subjects is that it can increase attrition. If more time is required, if there's more treatments and more conditions, likely that's going to require more time commitment. And so the participants may drop out because they don't want to keep coming back and getting measured, or it's too long of a time commitment, or whatever the issue may be. Also, as I said before, counterbalancing is more difficult as the number of treatments increases. And so that is also a disadvantage. And then the stats for this, it's not written on here, but it is a repeated measures, ANOVA, again, with more than one treatment, more than two treatments or more than two conditions, you have to use an ANOVA. You can no longer use a t-test. And so it's just that repeated measures ANOVA. If it is other types of data besides ratio, then it's more advanced statistical analyses that we're not really going to talk about here in this textbook. And so if you ever came across a situation like that, there are other textbooks that are more advanced that delve into that more and that you could check. So what is the negative side to a study with only two treatments that provides only two data points? And we literally just talked about this, but this kind of goes into a little bit more detail. So you can demonstrate the difference between conditions, but it's not showing the full picture, right? It's not showing that functional relationship between the independent and dependent variables. So we're not sure how the dependent variable would respond to small gradual changes of the independent variable. If there were those more subtle differences, would it change the way that the dependent variable responds, right? Or how it changes. So that is the knowledge check there. And then let's go to our learning check here in the book. What is the appropriate hypothesis test for within subjects design comparing mean differences for 3 treatment conditions? And since there's more than 2 treatment conditions, hopefully you know that is a repeated measures analysis of variance, or ANOVA. Remember, that's what ANOVA stands for, is analysis of variance. Then number 2 is which of the following is an advantage of a 2 treatment within subjects design compared to multiple treatment design? So when you only have 2 conditions, what's the benefit there? And if you look through these answers, it does reduce the risk of participant attrition, again, because it's less time commitment and less times being measured. It does actually also reduce the risk of time-related factors because it's less time. And it is easier to counterbalance a design with only 2 treatments than it is with more. So the answer would be all of the above. So there is that. And so that is the end of chapter 9, believe it or not. And so we have our little self-assessment review here. So, which of the characteristics of a within subjects experimental, what are those characteristics? And the main thing I want you to remember is that it's the same participants in each group, and that they are, being repeatedly measured, that repeated measures, right? And that you don't have to worry about those individual differences in a within subjects design. Second question, how can time-related factors and order effects threaten internal validity? Remember, those are those things, the history effect, the maturation, the instrumentation, and of course the order effects, the practice, fatigue, and carryover effects. And remember, those are influencing the dependent variable. And if they're influencing the dependent variable, then obviously that is a threat to internal validity, because it is something other than the independent variable that is affecting the dependent variable. Third question, under what circumstances is it advisable to switch to a between subjects design instead of using a within subjects design? And remember, that is when you're worried about time, those time threats we just talked about, time-related factors and order effects. If you are worried about any of those things, you think they're likely to affect your experiment, then you need to use a between subjects design, because with that design you don't have to worry about any time-related issues or order effects. And then the last question, what are the disadvantages of a multiple treatment design compared to a two treatment design? And again, we just talked about that. With the multiple treatment design, it is a lot more complicated, right? In general, counterbalancing is more difficult, and the people may drop out, the attrition increases, and then you may not be able to detect the significant difference if the changes between the conditions is too subtle. All right, so this is your summary. Remember, these are your chapter objectives. There was 8 of them. Remember, these are also at the beginning of your chapter. Make sure you understand these, and that you, make sure that you know and understand all of these things. Make sure you look at the key terms. Make sure you read the chapter summary at the end of the chapter, because that always is a very good wrap up of everything. And so, yeah, if you guys have any questions about anything from chapter 9 or about within subjects designs, just let me know, and I'm here.